I had a request from a student to go through a difficult quadratic equation question. So this question here says solve x squared plus 6x plus 2 is equal to 0. Give your answer in the form a plus or minus the root of b, where a and b are integers. Okay, so let's just talk about this question first. So before diving in, let's just have a little look into, well, the solution to this question, because, well, they're telling you to give your answer in the form a plus or minus root b. So what that means is you cannot use the usual procedure where you put it into two brackets, and where you find two numbers that multiply to give you plus 2, and add or subtract to give you this b value, the number in front of the x. I mean, that wouldn't work, because if you think about those examples, what those examples do is they give rise to rational solutions. So solutions such as whole number solutions or fractions, something like that. But we have to give our answer in the form a plus or minus b, or the root of b, and, well, the root of b is, that could be irrational. That could be an irrational number, because that b, we don't know what that b is going to be. So because our answer is going to contain a root, what that means is you'd have to use either the quadratic formula, or you'd have to use the completing the square formula. You could use that as well. So you can use any of those two options. Because remember, there are three ways to solve a quadratic equation. One being we set it out into two brackets and you use trial and error. That's one way of doing it. Or the other methods, the guaranteed methods, are to use the quadratic formula or the completing the square formula. So, I mean, out of the two options, quadratic formula or completing the square formula, quadratic formula is the safer option, because this is actually given to you in the paper. If we go to the formula sheet at the beginning, it's actually given to you there. So the solutions of ax squared plus bx plus c, so for any values a, b, or c where a is not equal to 0, are given by this quadratic formula. So you just simply plug in those values and simplify them. So this is obviously the safer option because you've been given it. I mean, you may not remember the completing the square formula. So if that's the case, if you've forgotten it, then I would go by this. Your best bet is to use this. But if you know both, go with the one you're more comfortable with. That would probably be completing the square. I think completing the square is slightly more easier because it's not too difficult to remember. If you use a tap, and a tap is a trigger action principle, to understand what a tap is, you'd have to go through my GCSE Maths in 4 weeks program. So that's available from the main website at www.passgcsemaths.com. With taps, it's just an alternative way of learning. You're not necessarily getting too bogged down with formulas. By using triggers or using phrases, it helps you to understand the content better. So let's just use the completing the square formula instead. So let's go back to that question. That was question 18. Right, so let me just show you what the formula is first. So this is the formula. Okay, so the formula is, okay, completing the square. The reason why it's called completing the square, because what we do is we put it in a squared bracket. So we'll have x plus b over 2. So what that means is it's whatever b is, but you half that value, all squared, and then you minus that value squared. So you minus that b over 2, whatever happens to be. So remember, this can vary. This can vary, depends on the nature of your quadratic equation, or the values a, b, and c. So you minus that value squared, and then you plus the c value. Okay, so if you compare it with our quadratic equation above, our a here is just equal to 1. Well, we don't necessarily need to know a, but let's just jot this down anyway. So a is equal to 1 here. That's the value in front of the, well, in all cases, if you're using completing the square, you can only use it when a is equal to 1. So when it's not a is equal to 1, so when it's greater than 1, then you would have to use the quadratic formula. So when it is a equal to 1, the coefficient in front of x squared, then you can just use a completing the square formula. So a is equal to 1 in this case, when we don't necessarily have to, that doesn't make that much of a difference to the question. So a is equal to 1, b is equal to 6 in this case. Okay, just be wary of the signs as well, because you have to take into account the signs, but in this example the signs are positive. So b is equal to 6 and c is equal to 2. So what you do is you just sub all of that into our formula. So what we'll have is we'll have this. So we'll have, well, b over 2 would be 3 in this case. 6 divided by 2 is equal to 3. So we'll have x plus 3 all squared minus this 3 squared. So remember, b over 2 is 3. So we have to minus that same value squared. So minus 3 squared. And then plus the c value, which is a 2. So plus a 2. Okay, so remember, this means the same thing. So this is exactly the same as this here. So those two are exactly the same. I'll just jot that down as well. So x squared plus 6x plus 2 is actually equal to or the same as the right hand side. So all of this, once we complete the square on it, it's exactly the same. And what you can do is you can expand all of this out, and what it will do is it will reduce to this left hand side here. So that's, the reason we do that is because we put it in a solvable form. So once you use completing the square, it's actually in a solvable form. So if you look back at our original equation, if this whole thing is equal to 0, this means this here is equal to 0. If they are indeed the same thing, this here is all equal to 0. Right, so let me just simplify this a little bit, because we've got this bit here on the end, the minus 3 squared plus 2. We can simplify that. So what we'll have is we'll have x plus 3 all squared, and we have, well, 3 squared is 9, and then we have a plus 2. So what we'll have is we'll have a minus 9 add 2. Okay, let me just make that a bit clearer. Remember, this is a squared here. So we'll have minus 9 plus 2, which will give us minus 7, wouldn't it? And that will be equal to 0. So what I've done is just gone a step ahead. So I've just simplified this end bit here. So we have a minus 9 plus the 2, which gives us minus 7. Okay, so now we can go ahead and solve this. It's in a solvable form. Okay, so let's just bring that minus 7 to the other side. So what we're left with is we're left with x plus 3 all squared is equal to, so if you've got a minus 7 on the left hand side, it becomes a positive 7 on the other side. Remember, you're doing the inverse operation on the other side. Okay, so x plus 3 all squared is equal to 7. Okay, and now what we need to do is we just solve it as normal. So it's just like a normal equation. So what we need to do is we need to isolate this x term, and we need to put it on its own. So if we've got x plus 3 all squared, we just need to square root both sides, don't we? So we square root both sides. And what that does is, obviously, it gets rid of this squared. Well, if you square something and then square root again, you're just back to square 1. So you're just left with x plus 3 is equal to, okay, remember, when you're taking the square root of something, so if you do the square root of 7, you actually give rise to two solutions. You have a positive solution and a negative solution. So whatever that square root of 7 happens to be, it's going to be in between 2 and 3, maybe slightly closer to 3. Maybe it'd be something like 3.6 something, but it would actually be plus and minus 3.6, whatever. So this here would actually be plus or minus root 7. And lastly, we just need to bring that 3 to the other side. So what we'll have is we'll have x is equal to minus 3, because it's a plus 3 on the left hand side, it becomes a minus 3 on the right hand side. So minus 3 plus or minus the root of 7, and that's it. So as you can see there, it is the same as, okay, that seemed to have dissipated there, so let me just quickly write that again. So what we had there is, so what you want to do is you might just want to rewind that and just pause it at that place where I had all the work in there. But what our answer is x is equal to minus 3 plus or minus the root of 7. And as you can see in this case, a is equal to minus 3 and b is therefore equal to 7, isn't it? Because that b value is 7 here, so that is your answer to that question here. So just remember, if it says to give your answer in this form, where a plus or minus the root of b, you can either use the quadratic formula or completing the square. The other method where you put it into two brackets wouldn't work, because that only works if you have rational solutions, so you have whole number solutions. But here we've actually got an irrational solution because of that root 7. Remember, root 7 is irrational because it's the square root of an unusual number. So, but also keep in mind that you can only use completing the square. So that's going to disappear now. You can only use completing the square when it's just an x squared. Because if you look at the formula, completing the square formula, so if you just want to rewind this video at the beginning, if you have a look at the formula, it only involves the b and the c value, which are these two values here. So it's the value in front of the x and that constant at the end. But that is the final answer to that question.